Intelligence Studio. Do subscribe and like the video.
We marvel at the vastness of space, but few realize the invisible threat lurking above. There are millions of pieces of debris orbiting our planet at this very moment. This debris, a collection of defunct satellites, rocket parts and fragments from collisions, poses a serious risk to active satellites and future space endeavors. Imagine a future where launching a telescope or sending humans to Mars becomes near impossible due to a hailstorm of space junk. This is the potential reality we face if we don't address the growing problem of space debris. What exactly constitutes this space debris? It's a question that has intrigued scientists and space enthusiasts alike. It encompasses a wide range of human-made objects orbiting Earth, from the tiniest flecks of paint to entire defunct satellites. These objects no longer serve any useful purpose, yet they continue to orbit our planet, posing a significant risk to operational spacecraft. We're talking about spent rocket stages, pieces of exploded satellites, and even tiny flecks of paint. Each of these items, regardless of size, contributes to the growing problem of space debris. According to NASA, there are over 23,000 objects larger than a softball being tracked. These are just the larger pieces. The smaller ones are even more numerous. The number of smaller particles like those from explosions or collisions is estimated to be in the hundreds of millions. These tiny particles, though small, can still cause significant damage. This debris, travelling at speeds up to 17,500 miles per hour, can cause significant damage upon impact with operational satellites or spacecraft. The sheer velocity makes even the smallest piece a potential threat. Even a small piece of debris can be catastrophic. The impact force is magnified by the high speeds at which these objects travel. Imagine a screw hitting a satellite at those speeds. The damage would be akin to a bullet striking a watermelon, causing immediate and severe destruction. These collisions create more debris, leading to a dangerous chain reaction. This phenomenon, known as the Kessler Syndrome, could make certain orbits unusable for generations. The Kessler Syndrome describes a scenario where the density of objects in low Earth orbit is high enough that collisions between objects could cause a cascade. Each collision generating space debris that increases the likelihood of further collisions. Scientists and engineers are working tirelessly to find solutions to mitigate this growing problem, from tracking and removing debris to designing more resilient spacecraft. As we continue to explore and utilize space, addressing the issue of space debris becomes ever more critical to ensure the safety and sustainability of our activities in orbit. The space debris problem is a direct consequence of our increasing reliance on space technology. Since the launch of Sputnik in 1957, the number of objects launched into space has grown exponentially. Satellites are essential for communication, navigation, weather forecasting, and scientific observation. However, each launch contributes to the growing cloud of debris. With companies like SpaceX planning mega constellations of thousands of satellites, the number of objects in orbit is projected to increase dramatically in the coming years. This increase in satellites will make the space debris problem even more acute. If we do not take measures to manage and mitigate space debris, we could face a future where space exploration and satellite communication are severely hindered. The Kessler Syndrome isn't just a theory, it's a very real possibility that we must address. The increasing number of satellites and space missions only adds to the urgency. We've already witnessed several collisions in space that have generated significant amounts of debris. These incidents highlight the immediate need for international cooperation and innovative solutions to tackle the growing problem. These events serve as stark reminders of the potential for a runaway cascade effect. Without proactive measures, the dream of a sustainable and safe space environment could slip through our fingers. Section 5. The Global Vacuum in Space Law. The lack of comprehensive international regulations for space debris mitigation is a major obstacle. The 1967 Outer Space Treaty, while a landmark agreement, lacks specific provisions for dealing with debris. It primarily focuses on the peaceful use of space and the prohibition of weapons of mass destruction in orbit. It doesn't adequately address the challenges posed by the 21st century space environment, where commercial space activities are rapidly increasing. Without clear guidelines and enforcement mechanisms, there's little incentive for nations or private companies to prioritize debris mitigation. This legal vacuum allows the problem to persist and grow. Section 6. SpaceX. Pioneering sustainable space practices. Some companies are taking the lead in addressing space debris. SpaceX, for example, has implemented measures to minimize its impact. Their Falcon 9 rockets are designed with reusable first stages that return to Earth for refurbishment and reuse. This reusability significantly reduces the amount of debris left in orbit compared to traditional expendable rockets. SpaceX is also developing technologies to deorbit their Starlink satellites at the end of their operational life. This responsible approach sets a positive example for other companies in the space industry. Section 7. Technological solutions, tracking and removal. Addressing the space debris problem requires technological innovation. Advanced tracking systems are crucial for monitoring the trajectories of debris and predicting potential collisions. Ground-based radars and telescopes play a vital role in tracking larger objects. Space-based sensors and lasers are being developed to track smaller debris, which is more difficult to monitor. Removing existing debris is another challenge. Concepts like space-based lasers to nudge debris into the atmosphere, robotic arms to capture and deorbit debris, and large nets to collect smaller particles are being explored. International collaboration is essential to develop and deploy these technologies effectively. Section 8. The environmental footprint of space debris. The impact of space debris extends beyond the immediate vicinity of Earth. When debris re-enters the atmosphere, it burns up, releasing chemicals into the air we breathe. While the amount of debris currently re-entering is relatively small, the increasing number of satellites and potential for collisions could exacerbate this issue. The long-term environmental consequences of these atmospheric pollutants are not fully understood. Furthermore, the uncontrolled re-entry of larger pieces of debris poses a risk to populated areas. While the probability of debris causing harm on the ground is low, it's not non-existent. Responsible space practices are essential to minimize these risks. Section 9. Our shared responsibility for space. The issue of space debris is not someone else's problem, it's a collective responsibility. Every piece of debris, no matter how small, poses a significant threat to operational satellites and future missions. Just as we strive to protect our oceans and atmosphere, we must also safeguard the space environment for future generations. The parallels are clear. Pollution in any form, whether on Earth or in space, can have devastating consequences. Raising awareness about the problem is crucial. Public understanding and support can drive policy changes and foster a culture of responsibility among spacefaring entities. Educating the public, policymakers, and industry leaders about the risks posed by space debris is the first step towards finding solutions. International cooperation is paramount. Collaborative efforts can lead to innovative solutions and shared resources for debris mitigation. No single nation can solve this problem alone. The interconnected nature of space activities means that debris from one country can affect satellites and missions from another. We need binding international agreements that establish clear guidelines for debris mitigation and remediation. These agreements should be comprehensive, covering all aspects of space activity from launch to end-of-life disposal. These agreements should encourage responsible space practices, promote technological innovation, and ensure the long-term sustainability of space activities. Investing in debris removal technologies and sustainable mission designs is essential. The future of space exploration, scientific discovery, and even our daily lives depends on it. Satellites play a crucial role in communication, navigation, and weather forecasting, making the protection of space assets vital. Let's work together to ensure that the final frontier remains a pristine environment for generations to come. By taking action now, we can preserve the wonders of space for future explorers and dreamers.
And do subscribe to the channel